Hello everyone. So today I will introduce the background and main idea behind our assessment plan for Stage 1 General Mathematics. So our assessment based on a public middle SES multicultural school. So now they are doing the year 11 general math. So most of the students will continue learning math in year 12, and most of the students often say that they don't really know why they need to learn math. A lot of students take the subjects only because their future major need math, such as IT or biology. So as a group of teachers, we wanted to build a whole semester assessment that helps students connect math with real life and develop their own understanding of why they need to learn math. Well, during our planning, we noticed that many students enjoy imagining their future home. Because of this, we create a semester project that guided students to build their own house through 3 connected assessments. So I will introduce 3 assessments very briefly. First one is about investing and borrowing, where students will use some financial math to compare different ways of purchasing land or building a house. The second assessment is about a statistic investigation, where students analyze real climate data from Adelaide to understand weather patterns and to see how climates will affect house design, like material and the orientation of house. The third assessment focuses on measurements, where students will design a blueprint for their home using some geometric concepts and also include their own cultural elements in their house design. And finally, students will publish all their work of these 3 assessments into a website. So how all these 3 assessments link directly to real life? While students work with real financial decisions such as comparing loan options and understand the interest, they work with real climate data that affect everyday life in Adelaide, and they make real design choices that architect and homeowner actually face, such as selecting material, planning structure of house. And for house design, it's also linked to students' own cultural background. Well, these real-life elements matter because they help students understand the purpose of mathematics. Instead of working on abstract exercise, they see how math supports real-life decisions they will make as adults since they are already year 11 students. For example, some financial math will help them understand a long-term cost and avoid risk borrowing. Climate data helps them build data literacy and understand the environment they live in, and designing their own house allow them to express their cultural identity while applying measurements and geometry in a meaningful way. Most importantly is that these tasks make math feel personal, relevant, and practical. Students can see how math is connected to their future life, where they live, how they plan financially, and how they make decisions in the real world. So our goal is to help students develop a sense of belonging in math and understand that mathematics is not just a subject, but also a useful tool for shaping their future.
I'd like to walk you through our revised learning and assessment plan for Stage 1 General Mathematics and explain how it aligns with all the concepts and techniques and reasoning and communication assessment criteria. Our LAP includes 3 topics: investing and borrowing, statistical investigation, and measurement. In topic 1, students analyze real financial situations such as loan repayments and compound interest. They write a short report using calculators or Excel to model repayment system and the long-term financial effects. Topic 1 addresses CD1, which is the orange part, so that students understand the interest and the loan concepts through this assessment. It means CT2 and students to choose formulas and spreadsheets to find the solution to the problem. And the CT4. It is achieved through their use of a spreadsheet to find the solution to the problems. And move on to the reasoning and the communication criteria. Students interpret results for RC1, and students present conclusion from analyzed results for RC2. And the last green one part is where students communicate clearly in their report for RC4. And the test prediction like interest rate change for RC5. Topic 3 is a group investigation of real climate data. Students create box plots, trend lines, and summary statistics, and present their finding in the 10 minutes group presentation. So CT1 is shown through statistical concepts to let students know the relationship between the delta and the distribution. CT3 happens when they use various model chains, and the CT4 is achieved through Excel for delta processing. For the reasoning and communication criteria, students interpret graphs for RC1 and draw conclusion for RC2 and predict the climate pattern for RC5. The final topic unifies everything. Students design a culturally meaningful home using measurement, geometry, climate data, and cultural influences. Their final product is a website explaining their calculations and the design choice. CT1 is shown through scale, area, parameter, and volume, and the RC1 appears as well because students also interpret their measurements at the same time. CT2 appears through particle problem solving, and it also meets RC3 because it is shown through accurate diagram labeling. In the orange part, CT3 is represented through the architectural model itself. And CT4 appears through digital drawing and website tools. In the purple part, RC2 is when they justify choices based on the climate and culture. And RC4 is the written explanation on the website.
Okay, so now I'm going to talk about how our 3 assessment align with the 2 core dimensions of the SACE Thrive, which is open doors and shared success. So in the SACE, open doors is about students actively noticing the problems, seeking opportunities, and turning ideas into a workable solution. In math, this means that students are not just doing calculation or following the formulas. They are using modeling, reasoning, and creative thinking to explore different possibilities. For the financial task, students will face a real-life complex decision, buying a house with a loan or in full. They need to analyze the interest rate, long-term, and the total cost. And here, the math becomes a tool for generating strategies, helping students make more realistic decisions. And the second is to analyze climate data. The students will identify the trend and then make any recommendation for the future. So this task helps students realize that math is not only used to interpret the past, but also to predict in the future. Finally, in the home design project, the students will integrate the analyze from the first 2 tasks to design a building, which develop their ability of creating new solutions and turning analyze into a practical, workable design. These 3 assessments build on each other. So the first, learning to spot the opportunity, then explain them, and finally create a solution. So this is the key idea of the opening the door. Through math, we are not just helping students understand the world, we are giving them the tool to change it. And second is shared success. It is all about using math to connect people and communities, and also about making math understandable and useful for others. So in the climate investigation, students will work in groups with the same places, sharing their own experiences with the weather. Then they present their findings to the class, so this task asks students to turn numbers into a story that the peers can understand. Similar to the financial analyst tasks, students need to write a report for their family. They have to explain a complex topic like the loans or interest in a simple language. Then for the home design project, the students publish their work on a website, sharing it in a wider audience. They don't just show in a building, they also need to explain how math and culture come together, and this is where they demonstrate their contribution to the broader community. So you can see the progress from sharing to your team, then to the class, and to advising your family, and finally to contributing to the communities. That is how we teach students to share success and make math a common language for everyone. Alright, so this three assessment helps 21st century learners to develop two main types of skills. One is the math skills and another one is the community and the citizenship skills. On the math side, students continuously develop the problem solving and critical thinking skills. They solve complex real-world problems, analyze data, and propose optimal solutions. This trains them to think logically, compare options, and innovate in the real life. The digital and technology skills are also the key. Across all three assessments, students use digital tools for their data processing, modeling, and share their work online. This helps them handle information efficiently and turn their analysis into an actionable, shareable result. On the community and citizenship side, the students practice collaboration and communication. In all three assessments, they work with the peers, share their analysis and the result to various audience. This moves the math beyond individual work into a teamwork and community engagement, while also building their ability to explain complex ideas clearly. At the same time, through the independently solving problem in assignment 1 and 3, students demonstrate a strong agency and self-directed learning. They actively analyzed, judge, and propose solutions in uncertain situations. And they can see the value of their work for both their team and community. Through group work, data sharing, and presenting to the real audience, the students see how their effort mattered to their team and the community. And this helps them feel connected and build a strong sense of belonging in their learning.